So this is a course I'm going to work through for creative coding. It covers the fundamentals of physics of the natural world and how to recreate them with code. So yeah, it just has a bunch of different chapters for different topics with interactive examples and everything. So what I want to do is have just like a creative coding notebook that's pretty easy to use. And this is what I've started working on here. So I'm using a solid and this solid command palette. And I actually submitted a PR for this functionality where I can have things nested without them showing up at the root, because before just everything was showing up at the root, and this potentially will have hundreds of pages, so I wanted the option to kind of keep them nested and tucked away. And I also added the functionality to load those groups via key binding because that was not working. So I can jump right to my grouped pages, navigate that way, or I can jump right to all of the pages and search there, and still have access to kind of like other commands that I might have for sketches. Like I might have some commands that are sketch specific to run there. So yeah, that's what I have set up. I'll show you a few of the sketches here. So that's the first one. So basically, like right now I just kind of have the same projects copied and pasted into 4 different files, but in reality it'll just be completely different sketches. So here I just changed it up by modifying the parameters a little bit in each one, and you can see we have some kind of reactive stuff going on there. So the way that's set up is I have this context function, and you pass it a declarative definition of these utility wrappers that I set up that will end up creating some of the actual controls, which are usually composed in a very imperative manner. For example, you have to keep track of which targets you're adding the inputs to. So if you have a nested structure like this that has root level tabs and groups and nested tabs, you have to keep references to all those and explicitly add your inputs to that. So I just kind of set up a little build system here to loop through the map and build everything automatically. And so the way this works type-wise is these wrappers return a data object that has a type for discriminated unions, the options that are specific to the control, and a signal for reactivity. And in some cases there's a little bit more going on. So rather than having the signal at the root level, it has a nested signal for the values that I'm going to be primarily using. And then it also has a few utilities. So this string utility is for Tweakpane, because Tweakpane doesn't accept number values. It has to be an HSL string, kind of formatted like you would for CSS. And it also returns it that way. So I have this getter setter function to kind of convert it back to the value and use the setter of the value whenever it's updated. And then I also have this array utility for P5's color utilities, so that way I can just drop in the values directly with rest parameters. And yeah, this function here returns the object directly. It's just for the sake of typing it and making sure that it has the correct structure. And then when you pass that into this P5 page utility, it gets forwarded to the build here, and then that ends up generating the actual context that will be used. So for example, here we have the wave that was defined above, and it has all the signals, none of the data stuff, none of the types, none of the options, just has the signals and callbacks for buttons and everything, so you can just use them directly. So yeah, all these W instances, like those are all my reactive values. And the way that happens, I have some types here. So starting here at the innermost level of the hierarchy, we have a context entry, which has all of the possible types that can be accepted there. And then next up we have a group, which contains a record of context entries, and then a tab, which contains a record of groups. And then at the outermost level, that's the entire map, so it's a record of tabs. So then I have both the context type, and also I think it happens in P5. Yeah, so basically here, this type is converting the raw data map to the actual context that's going to be consumed. So I have this context value here, which says, hey, if it's a control, then forward the signal. If it's a button, then forward the callback, and otherwise it's as of right now that would be a separator, so then we're not going to pass that through. And the same thing happens here, but programmatically, to ensure that the context is accurate when consumed in the lifecycle callbacks. There's also the button implementation, which is a little bit more boilerplatey than I would like it to be, but the benefit is that it's fully typed and you get IntelliSense and everything. The alternative, I'm not quite sure that it would be possible to do it the way that I would like, which is to just define this right inside of there, because you'll get type recursion. Even trying to do it without this wrapper function, you'll get type recursion. So that was the most practical implementation that I could think of to maintain type safety within the callbacks that are passed to the buttons. I just noticed that I have this manual typecast here left over from a while ago, but yeah, that's actually not necessary. The types are still generated automatically. And another cool thing is that even though this object has no actual relation to this object, since this is entirely generated, I can still refactor through here since everything is thoroughly typed. So that should traverse all the way down to the usage point, which yeah, right here. This is an example of one of the wrappers for the Tweakpane controls. So I have this utility type set up, options.control, and it gets reused through all of the control wrappers. And basically the way it works is it takes the base options, and then you pass a set of keys that you want to be forwarded explicitly. So those get included here. That way I can kind of explicitly designate which of the options I want to forward from the Tweakpane API. And then also here at the end, this is a space for me to extend it with custom attributes. So yeah, this type is just kind of making a little reusable way for me to pick what I need from it, add some extra stuff, and then kind of plays into the rest of these types here. So this right now, it has like way more properties than are actually used in the sketch. It's just kind of a playground for me to like try out these controls as I'm building them. I still have a few that I need to write, but you can check that out here. So you can see I have some root level tabs, and then I can define root level properties, and then I can define folders and folders with root level properties and tabs. And yeah, I don't have to worry about doing all that manually. I can just kind of like define it, have some nice little utilities here to just kind of like generate those tabs automatically. You can see that these functions are reactive, so that would not happen by default in Tweakpane. That's specifically because of the adapter that I set up between Tweakpane and Solid's signals. So that's going on down here, I think. Basically, the way that I accomplish that is I create a context proxy. It's not an actual like node proxy, but just kind of like a mock context that gets some getters and setters per value, and that's what interacts with the actual signals from Solid. So, and then this is how I make sure that it's bidirectionally reactive. So, for example, here, these are all being updated programmatically in this set interval here. So I'm calling the signals and manipulating them in different ways. So yeah, that's what's going on here. And even though these values are actively being programmatically manipulated, I can interact with them manually as well, and it's not disrupted. So yeah, that's kind of what I've been really working on the last few days, is making it so that there's bidirectional reactivity between the manual controls and the programmatic access to the signals, as well as derived values like any properties that are related and affect one another. So all that stuff kind of can update and keep in sync, and I don't have to worry about handling it manually once the definition is created. I think that's about it. That pretty much covers the gist of what's going on here and kind of like how I've been interacting with TypeScript and Solid. So yeah, I hope that gives you a good idea of kind of where I'm at with those particular tools.